We're going to look at the first trigonometric ratio today, the tangent ratio. Our goals are to understand what the tangent ratio of a right triangle is, and then to ultimately use this ratio to find sides and angles in a right triangle. Remember, we know some right triangle stuff, Pythagorean theorem, but Pythagorean theorem only works for sides, and it only works when you have two sides of a triangle. So Pythagorean theorem is really good, but it only works for a certain kind of triangle question. The key ideas from that introductory activity I asked you to do the other day was angles in a right triangle do not depend on the size of the triangle. It depends on the sides. So the idea there is if you change one of the sides of a triangle, you have physically changed the triangle and you have physically changed the angles, and that's what I hope you saw. The other key idea is if the sides are in the same proportion, for example, one triangle is twice as big as the other, then the angles remain the same. So again, that's a big difference. So here's an example of two triangles that have the same angle. So I'm just going to make it up. And you're going to imagine that these measurements are correct and these angles are correct. And if you did make a triangle like this, they would be correct. But what I want you to notice is the triangle on the right is, we could say 3 times as big as the triangle on the left, but the angles remain the same. So this is that idea of that second bullet. And again, the angles are the same. Now that's actually very powerful, because what that means is we don't have to treat these triangles differently, and we're going to develop an equation that's going to solve triangles like this. The other key ideas were smaller angles are opposite smaller sides and bigger angles are opposite bigger sides. So imagine two pencils making a V, and you put an elastic band at the open end. If you spread out the pencils and still keep the V, the elastic band would get bigger. So for instance, if these were my two pencils and here's my elastic band, well, here's that angle, small side. If we stretched out our two pencils, the angle between them would be bigger, and the side opposite would also be bigger. So that's that key idea right there. And again, angles change when you change one or two sides, that idea we said above. So again, a quick little diagram. If this is a right triangle and the vertical side is 1, and the horizontal side is 4, just have a look at that little angle right there. We'd say, well, it looks kind of small. If I change the vertical side to say 3, and I left this one as 4, again, what I would hope is I'd hope you'd look at that angle and go, that angle got bigger. So those are the key ideas I hope we saw in the introductory activity, and this is going to be our key idea moving forward. This is going to be the most important thing. Angles depend on the ratio or comparison of the lengths of sides. That's how you change angles. If you change how long one side is of a triangle, then automatically other things change. So this key idea is not the same as the key ideas above. Angles do not depend on the size, they depend on the sides, and we're moving forward with that one. So In order to solve some triangles, then, we need something more than Pythagorean theorem. And what the ancient mathematicians came up with is these trigonometric ratios. So if you look on your calculator right now, what you'll see is, you'll see a sine button, S-I-N, a cosine button, C-O-S, and a tan button, T-A-N. And what you can imagine is, you can imagine that those are built-in formulas that when you press those buttons, the calculator is going to do something for you. And everything your calculator is going to do for you is based on the sides of a right triangle. So right triangles have three sides, and one of them, as you know, is the hypotenuse. And the hypotenuse is always the angle, is always the side opposite the right angle. I'm going to use a little bit different vocabulary right now. I'm just going to call this the vertical side, and I'm going to call this the horizontal side. And we're going to change that vocabulary a bit at the heart of it. One of them is vertical and one of them is horizontal. So as you see, there are three trig ratios, and these trig ratios represent a specific relationship, or another word that you might think of as combination, between the sides of a triangle. So there are three combinations that we're going to have to worry about. There's, when we look at the vertical side and we compare it to the hypotenuse. And in grade 12, you'll actually reverse that. But for grade 10 and 11, we only worry about this. And then we have the relationship between the horizontal side and the hypotenuse. And finally, the other combo that's left over is the vertical side to the horizontal side. So these are the only combinations that we can make with three sides. And basically what it says is, if you change a vertical side, you're going to change the way the triangle looks, and then you're going to change the angles, and you're going to change the hypotenuse and all those things. So in order to use these special formulas, which I'll call sine and cosine and tangent, what we have to be able to do is identify the sides of a right triangle. And this might sound really simple, but it's really, really important. And as you see here, I say when you identify the sides, it's a relative statement. And by relative, I mean this. It depends on which angle you're talking about, we're looking at. So I'm going to color code my sides. But A is blue, B, and C. Now, when you look at the things that we're going to do, I'm always going to label my right triangle like this. A, B, C, and C is always going to be the hypotenuse, and C is going to be the right angle, and the hypotenuse is always opposite the right angle. The hypotenuse never changes. It is what it is. So we need a way to identify the sides instead of vertical and horizontal. So what we're going to use is, we're going to use two other words besides hypotenuse. We're going to use the opposite and the adjacent. And again, usually opposite is easier for you to understand. Opposite just means across from. So with respect to angle A, this side right here, with respect to angle A, this side right here is the opposite side. And again, I'll color code it. Black letter A, black opposite. And this side right here is the adjacent side. And if we can identify that, it makes it really easy to solve trigonometric equations. If we can't, then you're always going to be wrong. So again, opposite means across from, adjacent means touching. But again, what you might look at right away, you might go, well, the hypotenuse is touching angle A as well. So this side is obviously touching angle A, but the hypotenuse is also touching angle A, so shouldn't the hypotenuse be the adjacent side? And the answer to that is no. The hypotenuse is always the hypotenuse. It's special. So relative to angle A, we have the vertical side is opposite, the horizontal side is adjacent. But what about with respect to angle B? With respect to angle B, the horizontal side now is opposite across from angle B, and the vertical side is adjacent to angle B. So this is what I mean a relative statement. Depending on what angle you look at, the sides, the vertical and the opposite vertical and the horizontal take on different meanings. So we don't want to use vertical and horizontal. We want to use opposite and adjacent, and the easy way to do that is simply draw yourself a picture. So that leads to our first trigonometric ratio. Now you want to simply think of these as a formula. And your calculator has this formula pre-programmed into it. So at this point, really what we want to be able to do is we want to be able to use this formula just like you might use Pythagoras and plug in the right things and then do a calculation. So remember, Pythagorean theorem has a squared plus b squared is equal to c squared. There's three things, three unknowns there, and you have to know two of them. Well, that's exactly like this formula right here. Remember, this is a button on your calculator. This is a do something. So as soon as you press this button, your calculator knows you want it to do a certain thing. These are the three things you don't know, just like Pythagorean theorem. This is the symbol for an angle, and this represents one of the sides, and this represents the other side. So again, if we just treat it like a formula, trigonometry is pretty straightforward. So let's have a look at three examples of the tangent ratio and work through them. Now, there's three kinds of equations you need to be able to solve, and I'm going to do one example from each of them, and I'm going to introduce a little thing that will hopefully help you. So here's our right triangle right here, and what I want to find out is x, and what I hope you look at and see is the Pythagorean theorem will not work because you only know two sides of the triangle. Well, the really great thing is the tangent ratio is your new formula where you can use when you have two of the three pieces of information in that formula. And we do have two of the three pieces of information. We have an angle, we have a side, and we want to know the other side. So that brings us to my first little word, WIK. This is a good thing to do. Gets information out of your head. Here's what WIK means for me. It means what I know or want to know. And as we learn more ratios, this is going to help us decide which one to use. But today we're always going to do the tangent. So here's what I mean. What I know or want to know. Well, I know angle A. I know this side right here, which is the adjacent side to angle A. And I want to know that side right there, which is the side opposite angle A. And if we look at our tangent ratio has the word opposite and adjacent into it. So by writing down what I know, it tells me, literally points out the ratio I need. And then all I have to do is plug in the things in the formula. So remember, we have the tangent of an angle is equal to the side opposite over the side adjacent. So now it's just plug things in. So the tangent of 27 is equal to the side opposite. Well, that's what I don't want. That's what I don't know over the side adjacent. And now we have a formula that has one unknown, and we can go ahead and solve it. Now, right now, you might be really uncomfortable with tan of 27. So remember what that is. That's just a number on our calculator. So if we got out our calculator right now and simply punched in tangent of 27, my calculator is going to spit out a number. And we talked about what this number meant. So in this case right here, then the tangent of 27 degrees is 0.5095, blah, blah, blah. We're always going to go to 4 decimal places to make sure we don't make any rounding error. So again, the nice thing now is we can simply get rid of that weird kind of math, and we can just have a simple equation like we're used to. So here's the first kind of equation we have to solve once we've found our ratio and put in the things in the right spot and gotten rid of that nasty tangent language. It's the equation where the unknown's on the top. And this is an easy equation to solve because we just clear the denominator to isolate x. And when we clear the denominator to isolate x, we multiply both sides by whatever's on the bottom. And what we end up with is x is equal to 2.5. So if we take our answers for size to 1 decimal place, that's going to be good enough. So here's what we've done. We used a new relationship, or a specific relationship. The tangent relationship. Tangent relationship is the specific relationship when you know the opposite and adjacent side of an angle. And it's allowed us to answer the question. And hopefully that answer makes sense. So let's look at the second kind of equation you have to be able to solve. So here's an example. And we're told angle B is 62 degrees. Again, we want to know the vertical side, and we have the horizontal. So again, we want to get in that habit of what I know or want to know. Well, what do I know? I know angle B. I know the side opposite of angle B. And I want to know the side adjacent to angle B. And again, in our formula, the tangent is equal to the opposite over adjacent, so that points out the formula we want to use. Again, we can't use Pythagoras because we only have one side. So in this one, we're going to have our tangent ratio. The tangent of an angle is equal to side over side. The tangent of 62 is equal to the side opposite over the side adjacent to. And again, if we don't like that tan 62, we get out our calculator, because our calculator will change that into a decimal. And it tells us the tangent of 62 degrees is 1.8807. So that's what I'm going to change it to, 1.8807. At this point right here, we're solving an equation. We're almost finished with trigonometry, but we're solving an equation. And in looking back now, how are we going to go ahead and solve this? Well, again, I'm going to give you the quick little shortcut, and we can talk about it when we look at some of your homework questions. So this one right here, instead of clearing the denominator, here's simply what you do. When the unknown is on the bottom, you simply switch these two places. And again, we'll talk about this in a homework question. And now we get out our calculator and we simply do that and we get 5.3. So here's the second kind of equation you have to be able to solve, where the unknown is on the bottom, and it's actually quite easy to solve as well. You just interchange. And finally, one last question, because this is the only other question I could ask. Well, what happens if you want to find an angle? So first of all, Pythagorean theorem is never going to work. Pythagorean theorem doesn't find angle stuff. It only finds It only finds side stuff. So in this one, we're going to use our trig ratios because those are the only things that work. So we're going to write down what I know or what I want to know. Okay, so I want to know angle A. And relative to angle A, I know the opposite side, the side opposite angle A. And I know the adjacent side, the side adjacent to angle A. And again, what that does is it points out the ratio that we're going to use. And we're going to do the exact same thing. We're going to write our ratio. We're going to put in our information that we know and the information we want to know. And this is what we end up with. Now, this actually turns out to be the simplest equation to solve for you, because all you have to do is push a button on our calculator. So you just have to push the right button on the calculator to get the answer. And here's the button you press when you want to find an angle. So if we look at our graphing calculator, if we look at our calculator right now, we've been pushing the sine, we've been pushing the tan button. But what you should notice, right above the tan button on my calculator in blue, you'll see tan to the negative 1. Tan to the negative 1 is the button that tells your calculator, tell the person the angle. So that's the button we're going to push. So in this one right here, in order to find our angle, we're going to have to look at the tangent button, but what we're going to push is, we're going to push the second button. Now any decent calculator is going to have this, and we're going to press second, and then we're going to press the tan button. And when we do that, what you're going to see is, you're going to see this, tan to the negative 1. And then what we're simply going to do is we're going to plug in whatever that fraction is or whatever that decimal is on the other side, and our calculator is going to tell us the angle. So let me just show you what I mean by that. So in this one right here, I know that I have to find the angle. I know that the ratio that I've figured out is the tangent ratio. So I have to get to the blue button, and on my calculator, I go second tan. And then what I simply do is I put in that ratio of the sides, and I hit enter, and my calculator says 35.2. What it's telling me is the angle A is 35.2, so we'll just do a nice angle, 35 degrees.